Hello, I'm Carson Wright, a junior at Oklahoma State University studying biochemistry and molecular biology, and I'll be presenting my poster on NDVI use in predicting Bermuda grass yields. First, I'd like to thank Eric Messick, Tegan Crossweek, PhD student Giles Souza, and my mentor, Dr. Brian Arnall, for their help with my project. NDVI stands for Normalized Difference Vegetation Index. The specific NDVI device we used is the Green Seeker. This device sends out red and near-infrared wavelengths, then the optical sensor on it detects how much of those wavelengths are reflected off the Bermuda grass. The red light reflected is an indicator of less healthy vegetation, and near-infrared is an indicator of healthy vegetation. This device can be seen in Figure 1 and 2 below. Figure 1 is the top of the device, where reading between 0 and 1 is shown, with 1 meaning that there is the most near-infrared light reflected off the plants, and 0 being the least. Figure 2 is the bottom of the device, which has the sensors on it and faces the ground when taking measurements. These tools can be used to help predict future Bermuda grass yields. The objective of my research is to investigate if NDVI can successfully be used to predict Bermuda grass yields and when would be the best time to take NDVI measurements. For my materials and methods, my research consisted of one field that is divided into 2 different parts. Part of it is for pH trial and the other part for fertility trial. I did not split up the NDVI results between these fields because I'm mainly trying to just focus on between NDVI and yields. These fields consisted of 68 total plots that are 6.1 by 3.05 meters each. We took the first harvest on June 29th, 2021. We did not use any data from this harvest, but used it to start with a fresh field. We then took NDVI measurements with the Green Seeker on June 25th, 2021, July 9th, 2021, and July 16th, 2021. On each day I took the readings, I took a measurement walking long ways across the plot with the device in front of my hip with the device in front of me at hip level. Then did that again to where I got 2 readings for each plot each day and averaged those together. You can see me and Eric taking readings on plots in Figure 3 and 4 above. Then on July 23rd, 2021, we used a Carter harvester to harvest the fields and took biomass yields and sent off a sample from each plot to the SWFAL laboratory to determine moisture percentage. Now for my results. The first chart is a correlation between final dry yields and NDVI measurements collected on June 25th. The correlation is not very good, with an R-squared value of 0.0338, and the slope is negative. In this next chart, it shows dry yields and NDVI measurements collected on July 9th. This correlation looks a little better and has an almost horizontal slope, but is still not very good. In the next chart, it shows a correlation of the dry yields and NDVI measurements collected on July 16th. This chart has the best correlation of dry yields with an R-squared value of 0.1213. But based on these 3 charts, it does not appear that the NDVI is very reliable at predicting dry yields. These dry yields and NDVI measurement correlations can possibly be explained why they're muddy over some of the few next charts. The next chart shows NDVI measurements collected on July 16th and its correlation to biomass yield. This correlation has a good R-squared value of 0.5888 and a nice positive correlation. This shows that NDVI measurements taken a week before harvesting are fairly good at predicting biomass yields. The next chart up here shows a correlation between biomass yields and moisture percentage. This can help explain why our dry yield versus NDVI measurements don't have strong correlations, because the higher biomass samples will lose more weight when dried, and lower biomass samples will lose less weight when dried. In the next chart, we also see there is a good correlation between NDVI measurements on July 16th and moisture percentage. This could indicate that NDVI is pretty good at detecting moisture percentages. And this last chart down here shows a correlation between dry yield and moisture percentage. This chart shows that the lower dry yield samples had higher moisture percentage and that the higher dry yield samples had lower moisture percentage, which could explain a lot why our dry yield measurements with NDVI are fairly muddy, kind of all over the place, as it skews the results on both sides of the kilograms measured for each plot. Kilograms per meter squared measured on each plot. So from these results, we can say that the best time to take NDVI measurements for dry and biomass yields was July 16th, 2021, or a week before harvest. NDVI was not very good at predicting dry yield, but it was fairly good at predicting biomass yield and moisture percentage. The biomass yield also increased with moisture percentage. The possible reasoning as to why NDVI is better at predicting biomass yields than dry yields is that the green seeker takes measurements of biomasses in field and not dried out grass in fields usually, like compared to the dried samples that we have. Thank you for listening to my presentation, and I'd also like to thank everyone who helped me with my project at Oklahoma State University and in the RAIN program. My experience at the Rain-Fed Agriculture Innovation Network research experience for undergraduates has been overwhelmingly positive and very fun for this summer. I have learned a lot of new things about agriculture I did not know before, and I also learned a lot about what research exactly is and how to carry out research effectively. I know that this research experience will play a big part throughout my career in whatever I pursue. Thank you.